Hello everyone, welcome to Agri Addict YouTube channel. I'm your mentor Sakhi. Today I'll be teaching the second lecture of statistics lecture series. In that we'll discuss the measures of dispersion. This is my short intro. I have done my undergraduation from JNKV Jabalpur. Currently I'm pursuing masters at ICAR Hyderabad Hub Creda Department Agronomy. And in 2024, I have secured All India rank 12th in ICAR PG examination. Let's start with the lecture. In this lecture, we'll cover the measures of dispersion. In the previous lecture, we studied the measures of central tendency. So let's start with the lecture. Here you might be seeing the two types of measures of dispersion, that is absolute measure of dispersion and relative measure of dispersion. Okay. In absolute measure of dispersion, we will be studying these five measures of dispersion. This is range, quartile deviation, mean deviation, standard deviation, and variance. In relative measures of dispersion, we'll study the coefficient of variation, which is the most important. And you have to remember that these all other four are also the relative measures of dispersion. It can come under like which of the following are relative measures of dispersion or absolute measure of dispersion. Okay, so we'll in this lecture we'll be studying this coefficient of variation only. It is very important from our examination point of view. Okay, let's move to the next slide. First, absolute measure of dispersion is range. Wait a minute. It is the simplest measure of dispersion. Why we are saying it is simplest? Because it is to calculate range, it's very easy. What we have to do, we have to take the maximum value of the data series and we have to subtract it by minimum value of that data series. This is why we are saying it is the simplest measure of dispersion. For say we have a question in that we have 2, 4, 5, 6. This is a data series we have and we have to find the range for it. Okay. So what is the maximum value? Maximum value here is 6 and the minimum value is 2. Okay. So the 4 will be the range for this data series. So that's why we are saying it is simplest measure of dispersion. Okay. The range is the difference between the maximum and minimum values in a group of observation, just like I said here. Range takes only the maximum and minimum values into account and not all the values. Hence, it is very unstable and unreliable indicator of the amount of deviation. Why we are saying it is an unstable and unreliable? Because we are taking the minimum value and the maximum value only of the data series. We are rejecting the other two here in this example. So it can be a reliable indicator because we are not considering all the values given in the observation. So we are saying it is very unstable and unreliable indicator. Okay. The next point is it is affected by extreme values. Why? This I'll be describing you. For say one scenario is there here 2, 4, 5, 6 is there, and another scenario it is 2, 4, 5, and in place of 6 we'll be keeping 60. For this we have to calculate range. So it will be 6 minus 2, it will be 8. 6 minus 2, it will be 4. Sorry. And here what we'll be doing to calculate range, we have to take the maximum value, that is 60 minus 2, that will be 58. See, the difference between this and this is very much. Here it is 4, here it is 58. Just we have changed one value and it is changing. It is getting affected by the extreme value. So that's why we are saying that range is affected by extreme values. Okay, I hope you got the point. Let's move to the next slide. The second measure of dispersion is quartile deviation. In the previous lecture I have already taught that what is quartiles, but here I'll be revising it. Firstly, this is a data and we have to divide it into 4 equal parts. Then we'll be needing 3 quartiles. Okay, Q1, quartile 1, Q2, quartile 2, Q3, quartile 3. Okay, So, quartiles are the three positions in data series that divide the whole series into four equal parts. I hope you got the point. And quartile deviation is also known as semi-interquartile range. To understand this, we have to first know what is the formula of quartile deviation. Okay. So first we'll write the formula of quartile deviation. It is Q3 minus Q1 divided by 2. This is the formula of calculating quartile deviation. Okay. Now let's come to this point. It is also known as semi-interquartile range. Semi means half, we can understand. It's like half. Okay. So here we are saying it is the value is getting divided by 2. So we know why we are saying half, semi. Interquartile range. What we studied in the previous slide, what is range? It is the maximum value minus minimum value. So now we can say why we are saying quartile deviation as semi-interquartile range. I hope you got the point what I wanted to say. The difference between Q3 and Q1 and their average is called quartile deviation. That's what I taught here. It is more stable than the range as it depends on two intermediate values because it is more stable because here we are taking two intermediate, we are taking to Q3 and Q1. Okay. And it is not affected by extreme value. In the previous slide, we studied that the range is affected by extreme values, and we also did an example for it. And you might have got the point for that. Let's move to the next slide. In this slide, I have included this question. So we'll be finding the quartile deviation for this series. For finding quartile deviation, we have to first arrange this data. Arrange the data into ascending order. Okay. This is the first step. So what we'll do, we'll first arrange it like first will be 3, 4, 5, 6, 7, 9, 10, 12, 15. I hope we called all the ones. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Now we have arranged it. Now we first have to find, we know that in quartile what we studied, it is Q1, Q2, and Q3. Now we have to find our Q2 in this. We have to find the median. Okay. This we can see that this 7 is dividing all this data series into two equal parts. Towards the left side of the 7, there are 4 numbers, and toward the right side of the 7, it is also 4 numbers. Okay. So this can be regarded as Q2. It is quartile 2, or we can say median. Because here n is odd number. That is 9. Okay. 9 terms are there. So let's find out in the median, like measures of central tendency lecture, we calculated how to find the median. We just have to use that approach here. So how we'll calculate the Q1? In this is the let's take it as a separate data series. So it is having 4 observation. 4 is an even number. So what we'll do, we'll take an average of this two. 4 plus 5. 4 plus 5 divided by 2. So it will be 9 divided by 2. It will be 2 4s are 8, 2 5s are 10. So Q1 what we got is 4.5. Like this, here what we'll do, we'll calculate Q3. In the same way, here we'll take an average of 10 plus 2, 10 plus 12. So 10 plus 12 divided by 2 would be 22 divided by 2. It will come 11. Okay. Now what we have to do, we have in the previous slide we studied that what is the formula of quartile deviation. It is Q3 minus Q1 divided by 2. We just have to simply put the value and get the results. Here Q3 is 11 minus 4.5 divided by 2. Here we'll get 6.5 divided by 2. Now we'll get 2 3s are 6, 2 2s are 4, 2 5s are 10. It will be 3.25. This is our quartile deviation. I hope you got the point. Okay. I hope I was able to make you understand this concept. Let's move to the next slide. Then the third measure of dispersion is mean deviation. It is defined as the arithmetic average of the deviation of a set of a value, considering all positive, either from the mean or the median or the mode. This is called mean deviation. You might not get the point by reading this definition. I'll explain in the next slide. And one more important thing is it is also known as absolute deviation. Okay. Let's move to the next slide and then we'll understand the definition why we are saying this. So let's first derive the mean deviation with respect to mean. Okay. So the formula will be 1 by n summation of mode xi minus mean, or we can say x bar. Okay, mode close. This is for mean deviation of mean when we are calculating mean deviation from mean. If we are calculating mean deviation for median, then it will be 1 by n summation of mode xi minus median. Okay. Then for mean deviation from mode, it will be 1 upon n summation of xi minus mode. Okay. These are three formulas for calculating mean deviation. Okay. So let's move to the next slide, what we studied. It is saying that it is defined as the arithmetic average of the deviation of the set of value considering all positive. Why we are saying all positive? We are taking mode. In mode, all the value will come positive. We are taking arithmetic average. We studied arithmetic mean. In arithmetic mean, what we did, we take all the sum of observation, okay, and then we divided it by number of observation. Here we are dividing it by number of observation, and what we are doing, all positive value from either mean, median, or mode. That's what the definition says. If we are seeing the formula, we can understand what the definition says. I hope you got this point. Let's study the next point. Mean deviation is the least or minimum when taken from median. When mean deviation is taken from median, it comes to the least or the minimum. This point you have to remember. Okay. So let's move to the next slide. Okay, here I have included one question and I have solved it already. Here we have given this data xi 5, 10, 15, 12, 20 and 13. Okay. So mean deviation we have to we have to find it from mean. Okay. So this is the formula we'll be using 1 by n summation of mode xi minus x bar mode close. So now what we'll do, this xi will arrange in vertical order like 5, 10, not in ascending or descending order. Here we do not need that. 5, 10, 12, 15, 15, 12, 20, 13. Now what we'll do, we have to calculate mean for it. So now we'll be counting the number of observation. 1, 2, 3, 4, 5, 6. The number of observation is 6. What we'll do, we'll simply calculate the arithmetic mean. We'll add up the observation, divide by 6. Then the mean comes to be 12.5. Okay. So we wrote all, because for each value, the mean will be same. 12.5, 10.5. Now we have to calculate xi minus x bar. So what we'll do, we'll subtract it and then it will come minus 7.5. Here it will come minus 2.5. Here it will come 2.5. Here minus 0.5, 7.5 and 0.5. But what we are taking, here we are taking mode of it. So under mode, everything which is here, whatever the value is negative, it will get converted into the positive values. Now we have to take the, here what we are taking is the summation of xi minus x bar, okay, under mode. So we will sum it up. So it will come 21, okay. Now we have to put the value in this formula, okay. So it will be 1 upon n. N means 6 here. We are taking the number of observation is 6. So it is 1 upon 6 into the summation of xi minus x bar, which is 21. So if we will multiply it by 21, so 21 by 6 is equals to 3.5. I hope you got this question, how to solve, how to calculate mean deviation. Just like this, in case of mean we are doing, we have to do it for median also. For median, we have to arrange the data into the like ascending or descending order. Then we'll be able to find the median, and then we'll calculate in the same process. Okay, I hope you got this. Next slide. Okay, it is the most important one, I must say, standard deviation, the fourth one. Concept of standard deviation was introduced by Carl Pearson in 1893. It is important because it can be asked in a like match the following kind of question, like the concept given by the scientist and the name of the scientist. You have to maybe given to pair the scientist who gave this concept. So standard deviation concept was introduced by Carl Pearson in 1893. Okay, it has a practical significance because it is free from all demerits. We are saying it is free from all demerits because whatever we studied earlier, like range, quartile deviation, mean every all of those had some of demerits. So that's why we are saying it is free from all demerits. And because of that, we are saying that is its most important, stable, and widely used measure of dispersion. This can be asked as a question: which of the following is widely used measure of dispersion? So you should know that it is standard deviation. Standard deviation is also known as root mean square deviation. This you have to remember, root mean square deviation. Standard deviation is the square root of variance. Standard deviation is represented by, see, for population, when we have to find the standard deviation for population, it is represented by sigma. And when we have to find it for sample, it is represented by this Greek letter, which looks like S. Okay. So this you have to remember. For population, it is sigma, and for sample, it is this S looking like structure symbol. So standard deviation is under root of variance. Okay, standard deviation is denoted by sigma, and variance is denoted by sigma square. Okay, I hope you got this. Next, we have to first know how to calculate standard deviation. For that, we have to understand the formula. And for it, it is under root in bracket xi minus x bar square divided by n. This is how we have to calculate this is the formula for calculating standard deviation. Okay, I hope you understand. Now we will be solving these two examples and we'll be comparing how it is different, and we'll get to know one more concept. So first, first we have to arrange it. Xi, it will be 3, 4, 4, 5. Then x bar. So here n will be 4, and we have to sum this. Summation of xi, it is 5, 4, 4, 8 plus 8, 16. Then what we have to do, we have to calculate x bar. So it will be 16, because sum of xi is 16, divided by 4, it will come 4 4 is 16. So for each value, the mean will be 4. Okay, I hope you understand till time. Now we have to take xi minus x bar. So what we'll do, we'll minus this. Okay, so it will come minus 1. Here it will come 0. Here it will come 0 because 4 minus 4. Here 5 minus 4 will be 1. Okay, now we have to take the square of it. In the formula, it is mentioned that it is the square. So what we will be doing, xi minus x bar, its square we have to take. So minus 1 square will be 1, 0 square will be 0, 0, and 1 square will be 1. So now we have to take, oh, one thing I forgot to mention, it will be summation of, okay. So what we'll do the sum of xi minus x bar its square. So 1 plus 1 will be 2. Okay. Now we'll put the value in the formula and get the results. So it will be under root summation of xi minus x bar square will be 2 and n is 4. So here we'll be getting under root 2 divided by 2. So root 2's value is 1.414 divided by 2. So it will come 0.707. Okay. This is the first result we got. Okay. Let it be as regarded as SD1. Okay. Now in the same way we have to calculate this. So we'll be arranging xi as 2, 4, 4, 6. And we'll do the summation summation of xi. It will be also 16. Okay. So we have same the summation. Then here the number of observation is 4 as in case of here. So we'll be calculating mean. So we are getting 16. Okay. So x mean is 16 divided by 4. It will come the same 4. So here we'll be writing 4, 4, 4, 4. Now we have to do the same thing. It is xi minus x bar. Okay. So 2 minus 4 will be minus 2. 4 minus 4 will be 0. 4 minus 4 will be 0. 6 minus 4 will be 2. Now we have to do a square of it. Xi minus x bar to the square. Now 2 2s are 4. Here 0, 0 and it is 4. Now we have to take the summation of it. Xi minus x bar whole square. So it will be 4, 4. 4 plus 4 will be 8. Now what we have to do, we have to put the results into the formula and then get. So what is the summation of xi minus x bar square? It is 8 divided by 4. 4 is the number of observation. It is 4 2s are 8, that is root 2. It will come 1.414. Okay. So SD2 is coming 1.414. Why I'm telling, why we discussed two scenario is to, when we are saying that if the standard deviation, it is denoted by sigma, standard deviation is high means variability is more. If standard deviation is low, it means variability is low. This is what the concept I wanted to tell you. That's why I kept two data sets. Here we have seen that the mean is 4 in case of this also and in case of this also. Mean is same. Yet the standard deviation is different. Here in this case, in first case, the standard deviation is less compared to here. It means SD1 is less than SD2. So in this case, the variability will be less. You can see that 3, 4, 4, 5. Difference between these are not that much. Here in this case, 2, 4, 4, 6. The difference is comparatively more than this data series. So that's why we are saying SD1 means variability is less, and in SD2, in the second example, the variability is more. I hope you got the concept. So let's move to the next slide. Now some important point I have. It is an absolute measure of dispersion. In the first slide also we studied the same. It is expressed in terms of units in which the original figures are collected and stated. For say we are taking the standard deviation for plant height. So the unit for standard deviation will be centimeter. If say we are taking the seed weight, okay, then the standard deviation unit will be gram or kg. Okay, in terms of mass. The standard deviation of height of plant that is expressed in centimeter cannot be compared with standard deviation of weight of grains as both are expressed in different units. If we have taken plant height standard deviation, we cannot compare it with seed weight or weight of grains. Okay, because the units are different. So for that, what we'll be doing, Therefore, standard deviation must be converted into a relative measure of dispersion for the purpose of comparison. If we have to compare the two characters, then we cannot use standard deviation for that. We have to go for an relative measure of dispersion. Okay, the relative measure is known as this coefficient of variation, which we'll be studying in the coming slides. It is most important. If we have to compare two characteristics, we cannot use standard deviation. We have to use coefficient of variation. Okay, because it is unitless. It is very important. It is unitless and it is expressed in percentage. Okay, let's move to the next slide. Uses of standard deviation. First is to know the variability, as we studied in the previous slides. If standard deviation is more, the variability will be high. If standard deviation is less, variability will be low. Okay. The second is to calculate coefficient of variation. Coefficient of variation. Okay. Why? Here. Coefficient of variation, as I told earlier, it is expressed in percentage and it is unitless. So here what we'll be doing, standard deviation divided by mean into 100. Okay, this is the formula. So for calculating coefficient of variation, we need standard deviation. This is the second use of standard deviation. And the third is to determine the data dispersion. This is the third use. Okay, I hope you understand till now. Let's move. The third point I'll be explaining here, this to determine the data dispersion. In the next slide, I'll be explaining. So for say there is this graph. Okay. This is the mean value, mean. And if the mean is either added or subtracted by sigma, that is standard deviation, this is how we draw it. Wait a minute, some error has happened. First, I'll draw this. Okay. So this is the graph. Okay. This is the mean. Now we are adding or subtracting single this sigma, mu plus or minus sigma. So it will be like this. Okay. We are adding or subtracting. Here we are adding. In this case, from mean it is getting subtracted. Then the data coverage will be 68%. Let me use another color pen so you will get what I want to say. Okay. So this portion, okay, which I'm telling you, this, the 60% of the data will lie in this area. Okay, 60% data will be lying in this marked area. Okay, now let's come to the second scenario. Second scenario tells that mu plus or minus 2 sigma would cover 95%. Oh shit. Okay. 95% data. Okay. Now we'll be drawing this. 2 sigma either get subtracted or either get added. So it will cover 95% data. Let me change the color of pen. Okay. This will see the data coverage increased. Okay. The whole will be coming. So how many percentage of data is getting covered? 95% of data will lie between these two lines. Okay. Then the third scenario says that mu plus or minus 3 sigma will cover 99.7%. Means data coverage will be 99.7%. Let me draw this. Here it will cover, like, when we are adding 3 sigma or subtracting 3 sigma. Let me change the pen. Let me take this. So now the data coverage is this much from this line to this line. Okay, the 99% of the data will get covered, 99.7% data. So what will be coming? This graph I just made to make you understand. This will not come. This will come if the mu plus or minus sigma is there. Then how many like how much percentage of data will be covered? So it will be 68%. Mu plus or minus 2 sigma will be covering 95%. Mu plus or minus 3 sigma will be covering 99.7% data. That I wanted to make you understand. I hope you got the point. Let's move to the next slide. Next slide is of variance. The term variance was given by R.A. Fisher in 1913. So as the in the previous standard deviation slide, I said it will be coming in as maybe in the match the following, like that type of question. Variance is the square of standard deviation. Variance is denoted by sigma square. What is the formula for it? See, it is similar to standard deviation, but in standard deviation, we used to had this under root. Now, as we are saying it is sigma square, so this under root will not be there. Okay, so it will be summation of xi minus x bar square divided by number of observations. Variance is independent of change in origin but not scale. Means if we are adding or subtracting, here I have written it. If x is added to or subtracted from all data in a series, then variance will not be changed. Means if all the data for say 5, 4, 2, 9 like this, if we are adding something for say x in these or subtracting x from these all the data, then the variance will not be changed because it is independent of change in origin. But when we are multiplying or dividing it all the data by something for say x, if all the data in a series are multiplied with or divided by x, then the variance will be increased or decreased x squared times. Okay, this you have to remember. If we are multiplying it by x or dividing it by x, then it will be increased if we are multiplying by x square times. If we are dividing, then it will decrease by x square times. I hope you got the point. This is very important. This can be asked in the statement. Next slide is for coefficient of variation. Coefficient of variation is standard deviation by mean into 100. If we are calculating it for population, then it will be sigma upon mu into 100. If we are calculating for sample, then it will be denoted by this as like a symbol divided by x bar into 100. Okay. And it is the relative measure of dispersion. It is most widely used relative measure of dispersion. Okay. It's important. Next is the important points. Movements refer to the average of deviation from mean or origin raised to a certain power. Here, this is very important. You have to remember this. The zeroth central movement is equal to 1. This can be asked directly as a fact-based question. You can learn this as if the zeroth is there, then the answer will be 1. If first movement is there, the answer will be 0. It is opposite. Zeroth central movement, then the is equals to 1. First movement, central movement, it will be 0. Second movement, it will be variance. Okay. Third movement, it will be skewness. This we will be studying in the coming lectures. Fourth movement is kurtosis. So this you have to remember that zeroth central movement is equals to, then the option will be, the correct option will be 1. First moment, it will be 0. Second moment, it will be variance. Third moment, it will be skewness. And the fourth moment, the answer will be kurtosis. Okay. Let's move to the next slide. So let's start with the questions. If each data is changed by 2 times, then variance will be changed by dash times. The same question which I told in the previous slide here. If all the data in a series are multiplied by x, then it will be increased by x squared times. So here, what is x? Here x is equals to 2. Then the data will increased by or changed by 2 square. It means 4 times. So the answer will be 4. Okay, I hope you understand. Then calculate the CV if standard deviation is 20 centimeter and mean is 50 centimeter. So we studied that coefficient of variation is equals to standard deviation divided by mean into 100. So we just have to put the value. It will be 20 divided by 50 into 100. 50 twos are 100. So it will be 2 twos are 4, 40%. Do remember, then here 40 centimeter is also given, but we do not have to take it mark because we studied that coefficient of variation is a unitless value, unitless measure of dispersion. Okay, so the correct answer will be 40%. Okay, I hope I made you understand this concept, measure of dispersion. Thank you so much for listening to me and keep watching this lecture series. Thank you so much.